The next step is the actual chat form. The chat form is a form like the main form we discussed earlier. A chat with a specific contact which is passed in the constructor as we saw in the previous main form. We also have a getter for this property, which we used in the main class to check if the current chat contact matches the one in the incoming message. This is a common constant I use a lot to represent a single day in milliseconds. It's convenient. It probably should have been static as well. This is the date format used to represent the day label here. This indicates whether the blue label that says today was added. If not, when we type in the first message we need to add a label indicating that this message was sent today. The chat form uses the Y last box layout. This is a special type of box layout Y where the last component is pushed to the bottom of the form. So here we will use that position for the text field. Historically, I used to build apps like this with border layout and place the text field in the south. Both approaches are good with different trade-offs for each. This approach has the downside of hiding the chat text field when scrolling up, which is inconsistent with the way WhatsApp works, so you might want to revisit this with a border layout if you want that behavior. We use the chat form UI ID for the background image of the form. Here we use a standard title with the back arrow to navigate to the previous form. These are all the standard commands that appear in the WhatsApp application. I didn't implement them and just added them to create a similar design. The input container is this. We just add it to the box layout Y since it's in the last mode. It will glue itself to the bottom as long as it's the last component. From now on, we'll need to add all components before that component in the container. Now we go over the existing chats. So the UI opens with the content of previous chats stored on the phone. Each chat has a time. Time is represented in milliseconds since epoch, which is January 1st, 1970. We use that to divide the time by the constant we have for day. This will give us a number that represents a day since 1970. We can then check if the time from one chat is from the same day or from a different day. This can be tested with a simple not equals test. Notice I could have used code based on Java util calendar to do this test, but I think this approach is both faster and simpler. In both cases, we use add day to add this label before we add the chat content for a specific day. We then add a message to the UI. Normally when we add a component to the UI, we need to animate or revalidate the UI so it will show the component. However, since this code is running before the form is shown, we don't want such an animation as it might collide with the transition. The show listener is invoked when a form is actually shown. Here we can do things that will happen only after the form becomes visible. Notice I used an anonymous inner class instead of a lambda expression here. This is the reason. We can remove the show listener using this command if it's an anonymous inner class, but we can't remove it if it's a lambda, as this will map to the chat form instance. This is why we need this listener in the first place. This scrolls down to the last component. It's important to do this after the form is shown, because if it's done before, some components could still be laid out incorrectly. The add day method adds the day label if necessary. There are some nuances to this beyond the label alone. First, we need to check if today is the current day, since every day has a number associated with it. As we discussed before, this is pretty easy. If the day is today, then we need to add that special case label. We also need to flip the flag indicating that it was added. This Boolean flag is a special case that we will discuss later. There is another slightly simpler special case for yesterday, showing the previous day with a special matching label. Otherwise, we use the formatter we declared at the top of the class to generate the text of the day label. We create a label with the right style and add it before the text input component. Which brings us to the input container I mentioned before. This method creates that container which includes everything in this line, including the microphone button. The container starts with a text field where the messages can be typed. There are two important features we need in this text field. First, we don't want a border. We'll set the border to the parent container, which we defined as a pill border in the CSS. Second, we want this to be a multi-line text field. This allows us to type in longer messages and review them. However, it means that enter won't map to sending. The done listener is the first way to send a message. It can be triggered by using the device virtual keyboard when pressing done. This adds the message to the UI, and it does that with an animation that lays out the message on the form. After adding the message, we want to clear the text, so we stop the editing process and set the text to an empty string. This would have worked had we not stopped the wouldn't have worked had we not stopped the editing. These are the three buttons we see next to the text field here. The text field is between them and not under them. It just has no border. The round pill border is a container that surrounds the buttons and the text field. I'll talk about attachments soon. This isn't fully implemented, but I'll cover this when we reach these methods. The input container wraps these three buttons and the text field. We give it the chat text field UID, which includes the pill border. Finally, microphone has the record button design. There is a partial work here for voice recording. When we override pointer pressed, we can use the media recorder to start voice recording and stop it in pointer released. I eventually didn't get around to doing that. If there is text in the input field, the microphone icon becomes a send icon. Here we use the data change listener to track that and update the icon on the fly. The action listener is only applicable when the microphone is in send mode. It's used to send the text in the text field. This code is effectively identical to the code we saw earlier in the method. It might make sense to generalize this block. Finally, this method returns a border layout that pairs together the input container and the microphone as a single container. This is a utility method I use quite often to write a number as 2 digits. It's useful for formatting hours, so a number like 1 will be written as 01, etc. The logic is trivial. If a number is smaller than 10, return it with a 0 prepended to it. Otherwise, return the number as a string. I make use of this method in the time formatting method below. This method formats the time as hours and minutes used to display the hour next to the message. This method just gets the hour and minutes from the calendar class and formats them as 2 digits with a colon in the middle. We saw the add message method invoked when the user types a new message. It's pretty simple, as most of the logic in this method is delegated to the following add message to UI no animation method, but it does contain a couple of interesting bits. This is why we have the today added flag. If this flag isn't set, we need to add today to the dates before adding a new message. This method does the heavy lifting of adding a message to the UI. Here we animate the addition. Notice I used an and wait variant of the method. It's so the scroll component to visible below will work. This won't work during the animation, as the position wouldn't be correct at that point. This is the method that actually adds chat bubbles to the UI. This is the logic to determine if the bubble goes in the right or left. I used this logic so it will work even with groups. I could have simplified it if there were only two options. The main difference between the left and right chat bubble is the UI ID, as I mentioned in the theme. The actual component placed in the chat is created by a separate method. If this is a media component, we'll call create media message, and if it's a text message, we use create text message. The rest of this method styles the result of that method. The component uses the chat bubble. However, we need to know whether the component should have an arrow or not. Notice that if we have two chat bubbles, one on top, the other and the other from the same sender, the second bubble doesn't have an arrow. This is true for both sides of the conversation. However, if we have a message from someone else, then the arrow returns. This block tries to implement that logic by detecting this situation. The first condition is meant to detect a chat with no components in it. In this case, the arrow must be shown, so we can easily set the arrow on the correct side by using the left Boolean variable to determine that. Otherwise, we need to dig through the components we already added. The last component is the input component, so we need to look at the components before that. To align chat bubbles correctly, we use container wrapper. So the previous container is a container. We exact the first child of that container and save it into CNT. CNT is now the previous component. If the UI ID of the previous component matches our current UI ID, it means that the previous component pointed to the same side. That means we don't need an arrow. If the UI IDs aren't identical, the arrow needs to point into one of these directions. This is another special case. When the arrow is removed, we also want less space between the chat bubbles. This is a small nuance of the app that helps associate the components as part of the same conversation. We wrap the component in a flow layout so it will align correctly to the left or right side. We set the UI ID to the UI ID we picked at the beginning of the method. We add the component to the offset just before the input component. We store the message itself as a client property in the component. This makes it easier to implement features such as search, as we can easily determine the business object related to a specific component. Finally, we set the border to the component and return the container instance. This version of the method does all of that, but also sends the message to the server. This is the version of the method we invoke when a user types a message. This is the method that creates the components for a text message. As you recall, we have two methods, one for text and one for images. We use a text area to represent the text. It's more direct than span label, which is technically just a text area wrapped in a container. Act as label removes some optimizations from the text area, so the text is laid out accurately. It can make it slightly slower to render though. We block editing and focus so a user can't interact with the text area. We set the UI ID to chat text so it will use the right font and colors. Time is the label with the current time for this message. It uses the chat time style. Time is the label with the current time for this message. It uses the chat time style. Notice that short messages place the time next to the text, whereas long messages place it below. I chose to use the 30 character mark to decide this. A better strategy might have been to calculate preferred size in some way and decide based on that, but I wanted to keep things simple, so I chose this approach. Finally, we return the bubble container that includes the text and the time. The media message is similar, but it uses the media file URL. Right now, the method is designed only to work with images, but this can probably be fixed relatively easily. We open a file stream for the media. We calculate a desired size for the media, which is half the size of the portrait screen. We load the image, then scale it into a button as the icon of that button. Once there, we enclose it in a layered layout, so the time is overlaid at the bottom right of the layered layout. As you might recall, the open camera method was mapped as a listener to this button. It's a simple method that invokes capture and then adds the result as a message. The last method in the class is openFile, which is effectively identical. It uses the file chooser cn1lib API and maps to the attach button. It allows opening all files, but in order for this to work, we need to process all file types. However, I only implemented image support as I did in the previous method.